Good day to you guys. In this video presentation, we are going to discuss two examples under functions in the class, I'm going to clarify to you instances where symbolic visualization and spatial visualization are being applied. In the first example, we are given the function f of x is equal to 3 over x minus 4 plus 2. And in part 1, we are asked to determine the equations of the asymptote. Part 2 and 3, we are asked to determine the x and y intercept. And part 4, to sketch the graph. If you look at this example 1, you will notice that most of our learners are familiar with answering questions that are similar to example 1, where at the beginning you are given the function in symbolic form, and then asked to go through a few steps at the end, draw a sketch of the graph. Now in example 2, you will see that the way the questions are asked are slightly different. Example 2 reads, shown below is the graph of g of x is equal to a over x plus p plus q. So in example 2, you are actually given the graph of the function. And then you are then asked, just like in example 1, to part 1, determine the equation of the asymptote, and part 2, to determine the value of a given that point D lies on the graph, and then part 3, to determine the actual equation of the function. Right. Example 2, when you compare it to example 1, you notice they are in opposite to one another. With the example 1, they started by giving us the function f of x in symbolic form, and asking us at the end to draw a sketch of the graph. Whereas with the example 2, they are starting by giving us the graph of the function, and at the end asking us to determine the actual equation. So in example 2 solution, we are working backwards because it is opposite to example 1. We are starting from the given graph and we're working backwards to, at the end, determine the actual equation of the function. And most of our learners are not familiar with such questions, and we would need to train them to also answer them, because they can come in an examination. Let us discuss the two examples, beginning with the first one. Right. F of x is equal to 3 over x minus 4 plus 2 to determine the equation of the asymptote. From our previous workshop, you remember that Mr. Mchingizane indicated we can, from the given function in symbolic form, derive our equations of asymptote by looking at the denominator x minus 4, then if we equal it to 0, x minus 4 equal to 0, when you take the minus 4 across, you get x is equal to 4, which is the x asymptote. And then in the function, there is a plus 2, which means the graph it shifts by 2 units along the y-axis. That means that plus 2 it becomes our y-intercept, sorry, our y-asymptote. So our two asymptotes, it's x is equal to 4 and y is equal to 2. And we have determined this asymptote by reading information from the function itself in symbolic form. So when we are reading information from the function in symbolic form, we call that process symbolic visualization. So in deriving asymptotes for part 1, we are applying symbolic visualization, because we derive or read information from the function itself in symbolic form. Then part 2, determine the x-intercept of f. Here for the x-intercept, we put f equal to 0 in the equation and solve for x, so that our equation becomes 0 is equal to 3 over x minus 4 plus 2. And then we take this plus 2 to the other side, you get 3 over x minus 4 is equal to negative 2, which simplifies to x minus 4 is equal to minus 3 over 2, giving you x is equal to 5 over 2, which is our x-intercept. Part 3, determine the y-intercept of f. For y-intercept, you know that we put x is equal to 0 and make this fy, so that our equation becomes y is equal to 3 over 0 minus 4 plus 2. And then it simplifies to y is equal to minus 3 quarters plus 2, which gives us y is equal to 5 over 4, our y-intercept. And then the part 4 is asking us to sketch the graph of f, clearly showing all the intercepts with the axis and any asymptotes. For answering the part 4, we use the solutions we obtained in part 1 up to part 3. And if you look at part 1, our asymptotes are x is equal to 4, so we have a dotted line there, cutting it 4 on the x-axis. That is the x-intercept. And the y-intercept is y-asymptote, sorry, is y is equal to 2. So it is a horizontal line, cutting it 2 on the y-axis. And then our graph cuts on the x-axis, it's 5 over 2, which is 2.5. And 2.5 is between 0 and 4. So there is our x-intercept. Our y-intercept is 5 over 4, which is 1.25. And it also lies between 0 and 2. So 5 over 4 is somewhere there. And meaning that our graph cuts through these 2 points, the y-intercept and the x-intercept. Because our function is a hyperbola, it is a broken graph with 2 parts or 2 loops. The first part will pass through those intercepts, so it is represented by this curve here, while the other part is represented by that curve, and these curves don't cut across the asymptotes. So the graph in red is the sketch of the function f of x equal to 3 over x minus 4 plus 2, which answers our question, for example 1. So part 4, that becomes the sketch of the graph of f of x. Now with example 2, we are having shown below is the graph of g of x equal to a over x plus p plus q, and then determine the equation of the asymptotes. With example 2, we cannot determine the equations of the asymptote from the function itself in symbolic form, because we have 3 unknowns, PA, P, and Q. So we cannot, like we did in example 1, determine the equations of the asymptote from the function in symbolic form because of these unknowns. But we have to derive our equations of asymptotes by looking at the graph or by reading the graph. And when we're looking at the graph for information, you are applying the method called spatial visualization, because you are reading from a graph and not from the function in symbolic form. If we look at the graph, there is a vertical dotted line cutting at -2 on the x-axis. That is our x asymptote. The horizontal line cutting at 3 on the y-axis. That is y asymptote. So the solution from the graph, the x asymptote is x is equal to -2, and the other one is y is equal to 3. These are the 2 asymptotes, and we have derived them from the graph, which is the application of spatial visualization. Part 2, find the value of a if the point B with coordinates -1, -1 lies on the graph of g of x. Now, with part 2, if you see solutions of part 1, we are saying our asymptotes are x is equal to -2 and y is equal to 3, which means we can in our function, substitute our values of P and Q. I normally teach learners a simple way of looking at the x as asymptote. X is equal to -2. If you take this -2 across to the left-hand side, you will get x plus 2 is equal to 0. So the x plus 2 becomes the denominator in our function. So there is our x plus 2. And then this y is equal to 3 will be the plus 3, which is a shift by 3 units. So that our function g of x will be equal to a over x plus 2 plus 3. Meaning our value of p is 2 and our q is equal to 3. But a we don't know. In part 2, we are told point B with coordinates -1, -1 lies on the graph. Which means when x is -1, y is equal to -1. In the function, we replace g with y. So we put -1 here. -1 will be equal to a over x is -1 plus 2 plus 3. And then we simplify here, -1 plus 2 is 1. A over 1 is a. So that we have -1 is equal to a plus 3. Then we solve for a to get a is equal to -1 minus 3, which is equal to -4. So our a is -4, we can substitute it there to then have the solution for the function, for the equation of the function, part 3, as g of x is equal to -4 over x plus 2 plus 3. And that becomes the actual equation of the function g of x. So with example 2, the solution ends at that part 3. And if you look at the solution process, we kind of working backwards, which to the way we were determining solutions for example 1. I would like to our learners to be conscientized about how to answer such questions, where they actually read the information from a graph. Because in mathematics, you know what we have, guys, is mathematical information is presented in two forms. It's either in the form of symbols, which we call symbolic form, or in the form of diagrams, graphs, or a picture, which we call the visual form, right, or the spatial form. So the representation of information in either in symbolic form or in spatial form requires our learners to be able to move back and forth between the two forms, reading information, because there is connection between mathematics in symbolic form and the mathematics expressed as a graphical form. So the teaching of learners to be able to read mathematical information between those two forms and be able to even move from one form to the other is actually a recipe that will make our learners understand mathematics. And this method, which is the visualization and symbolization approach, applies both methods. And I would like to come to an instance where, if you look at the solutions, we said here we applied, for part 1, we applied symbolic visualization. Right? We applied symbolic visualization for part 1. But because the visualization and symbolization approach applies the 3 methods: symbolic visualization, spatial visualization, in addition to analytic methods, you will see that in a solution, all these methods will be applied in answering the question. For example, here I said for answering part 1, symbolic visualization was utilized. But when you are answering question 2 where you are determining the x-intercept, this is analytic. Method. And part 3,